Welcome students. Today is the 16th class on digital land surveying and mapping. Today I will be talking on quality of GPS surveying. That means whatever GPS data you have processed, you need to evaluate whether the quality of the processed parameter like position, baseline and network is of the quality required for the project need or not. So, today I am going to talk on that aspect, quality assessment of GPS surveying of point or position, baseline and network, and the topic will be covered under this following head. Of this, the most important is first two, that means first we need to know really what may be the standard or what are the standards really field engineers decided for different parameters of GPS parameters to be achieved. So, the standards that has been declared or evolved out of time has to be discussed, and there are two types, one is that position standard, another is the baseline standard, and the second one is that whatever we have processed or we derived from the GPS data, that processed parameters we need to test. So, to test we need to have some measures. So, in the second head, quality measures and define quality measures for point and baseline length and GPS network, that will be discussed. So, GPS surveying generally we do want to get the position of a point, the length of a baseline and subsequently the GPS network we do go for. So, all those things should satisfy the requirement of the project. So, before we go for any surveying work, we do first decide what should be the quality or what are the specification that the land surveying work should achieve, and that is what is the requirement of the, and that will depend on the requirement of the project. So, this is the thing which we decide before we start any surveying work. Now, after we decide the quality that the land surveying work has to satisfy, we need to test the quality of outputs. Now, that requirements of the projects actually we define on the basis of the standards that has been predefined and available, and that we will discuss as I told you, and then once we take the observations, then we need to test the quality of the output, whether it met the specification of the project, and to compare the standards we need to have some measures. That means we need to find out from the observed parameters, from the observed measurement we do compute the parameters and we will get the parameters. From there we need to derive some other quality measures which will define about the quality of the parameters which we have processed, and then those measures has to be checked with the standards. So, we need to know some measures. So, that is what it is told in this. Now, to start with that standards of for GPS surveying. Now, I will explain about the root mean square error. Root mean square error mean square error. Now, suppose for any parameter the true value is x, and for that parameter we have taken observation n observations. suppose x1, x2, xn, n observations we have taken. Now, for this observation set of observation, what is the root mean square error? That is, we can find by using a relation like this, x minus xi, the difference of the observed value from the true value, squaring it, then adding all the squares for all the n observations and taking a mean and then square root of this, that is the root mean square error of the observations of the observation. So it is the difference of the observed value from the true value, squaring of that, and then squaring of all for all the observations and taking a mean of that and then square root. So, this is the parameter we use for defining the standard or for GPS surveying. Now, let me take an example of the location of a position. Now, we know the position of a point can be defined by Cartesian coordinate x, y, z, or our planimetric coordinate north and east and orthometric height. Now, in case of 3D position, if we want to define, so suppose x, y, z are the true coordinate of point P, and for during some observation, suppose x1, y1, z1 is the first observed location, then x2, y2, z2 is the second observed, like that. If we take n observation, then we will have nth observation. Now, for this set of observation, the root mean square error can be written like this, x minus x difference xi whole square plus y difference yi whole square, z difference zi whole square, and summation of these for I equal to 1 to n and then divided by n square root. So, this is the 3D root mean square error for the position. Now, suppose I want to find out the root mean square error with respect to planimetric position, root mean square error with respect to planimetric position. So, in that case, as per the Cartesian coordinate, we simply take the summation of the x coordinate and y coordinate difference square and summation and divided by the number of observation taking square root. This will be the root mean square error in planimetric position of the point in Cartesian coordinates. Now, if we want to know what is the root mean square error of the point in planimetric position in local coordinate system, that is northeast. So, for that we need to have the north, east and orthometric height actual true coordinate of the point, and corresponding to these we need to have n1, e1, h1, n2, e2, h2 like this, N N E N H N. That means corresponding to each Cartesian coordinate, observed coordinate, we need to have the modified local coordinates, and for the planimetric position local coordinate system root mean square error, we can do it, get it by n minus n difference n I whole square E by difference E I whole square summation I equal to 1 to n divided by n square, like this. So, this is the root mean square error of the position with reference to planimetric position and in local coordinate system. Similarly, for the height we can get out root mean square error with respect to height equal to h minus h I whole square I equal to 1 to n divided by n square. So, now these values have to be compared with the standard defined, and as per the value we can say the quality or standard of the point, either 3D quality or 2D quality or height quality, we can find out by using these relations. There are so many standards available, widely available all over the world. Each and every organization may have their own standards. Now, in this course I have taken the specification published by Federal Geodetic Control Subcommittee of US as the standard for GPS surveying, because that has been adopted widely. FG standards for position and baseline. Now, is defined by root mean square error, and the position, actually there are two types of position. One is called planimetric position, so planimetric, and another is height. So, actually through GPS generally we get less accuracy in height than planimetric. So, planimetric position. So, the planimetric and height standards are to be defined differently. However, for both these actually the actual standard definition is same, but the amount may be varying depending upon your project requirements. Now, the planimetric position standard is defined by a circle of radius r, and height is defined by a line about the center of this. So, if this is the true location, we do define a circle having radius r. Generally we take r is equal to 95% confidence. So, 95% confidence interval, that means 1.96 sigma. So, if we have a point whose position is known, control point, so already a defined control point. So, whenever we define a control point, we define by its mean and standard deviation. So, if we take the position of the control point is this one, and the 1.96 sigma radius a circle. So, I can say this is the error circle within which I will get, if I get my position, then that position I can say that have the 95% confidence. Now, corresponding to this location again we can take a vertical line which is again for control point, this is the for horizontal position, and for vertical position mu and sigma. So again 1.96% we can take. So and if we draw this like this, so we will say we will get a cylinder. We will get a cylinder having 1.96, this is 1.96 sigma v and 1.96 sigma h, and if the position 3D position lies within this cylinder, then we can say that this position is having 95% confidence level, that it will be within this accuracy. So this is the way how we do define the standard. So now this is the way how we do define. Now the value of sigma, these values may be of different amount, and depending upon the amount of this value, sorry not mu but sigma, depending upon this value, this is the root mean square error. So this depending upon this value we can divide the different standard into 4 classes: millimeter, centimeter, decimeter, meter. Now within the millimeter again we can have 1 millimeter or 2 millimeter standard or 5 millimeter standard, centimeter 1 to 5 centimeter, decimeter 1 to 5 centimeter, decimeter, meter 1 to 5 meter, and finally 10 meter. So these are the 4 classes: millimeter, centimeter, decimeter, meter, and among each class there may be again 3 subtypes: 1, 2, 3, that means 1, 2, 3 millimeter, 1, 2, 3 centimeter, 1, 2, 3 decimeter, or sorry 1, 2, 5 decimeter, and 1, 2, 5 10 meter. So that means these values, depending upon these values we can have our cylinder 95% confidence cylinder, bigger or smaller. So depending upon how big or how small this confidence cylinder within which this position, unknown position lies, we will say that this is the level of accuracy, that is the level of standard. In case of baseline, what we do measure in some, the standard is defined in some other way, that is called using parts per million. So if we have a true length of a baseline, true length, and it is the observed length, so from there we can derive the change in the error in length divided by true length. Now this can be 1:, some value. So depending upon this 1:, this value, our standard will be defined. So lesser the error, higher will be this ratio, and better will be our order. So in that way you can see here that there are 7 orders in which the baseline can be defined, that means A order, B, C1, C2, C3, and even 2 also, 2, 1, 2, 2. So and the parts per million is this, that means 1 millimeter will be error in 1000, that means 1 millimeter is to, and if it is if I convert it to meter, then 100 kilometers, that means 1 millimeter error in measurement of 100 kilometer. If we can achieve this error in 1 millimeter error in 100 kilometer measurement of distance or baseline, then we can say that the order achieved is AA. In that way different orders has been christened and accordingly we can say. So, this is what is the standard. Whenever we will go for any GPS surveying, we have to make use of this standard for our comparison purpose. So, now the quality measures. So, quality measures. Now, it is the precision and accuracy, these are the two measures used as the quality, you are used to measure the quality of position or baseline. Now, what is precision? How do you relate this precision measurement with the standards? Now, as you know, the precision means having the measurements close to each other, and if I have a set of measurement like this, I will have a mean and standard deviation of the measurement. Now, if I see this sigma, now I will compare this sigma m with the standards we have for position with this value. So, wherever this value will be within this, then I will be able to tell that my precision standard, my precision has been achieved centimeter or decimeter or millimeter or 5 millimeter like that. So, and similarly for accuracy, if we know the exact location of any point, now I may derive this error ellipse as I told you, 1.96, that means 0.1, 0.01 millimeter, or I can get numbers of circles around this point taking these as radius. Now, suppose my suppose this is the position I got for a location, and if it falls within this, suppose somewhere here it appears. So, now suppose the radius of the circle is suppose 0.05, 0.05. So, I can say that the accuracy of the position is 5 centimeter. So, in that way we can define the quality of our position. Now, further we should see that the GPS position should satisfy these criteria. So, this is another point, that means this is the precision criteria. Now, for baseline, now this is for planimetric position. For vertical height also similar thing, I can we can think of a line. So, depending upon at what height beyond this point our point reaches, that according to that we can say it. Now, in case of baseline, for precision we do measure the as I have already discussed during the baseline processing, that in case of baseline we do find out the different component of the baseline, and along with this component we will get the standard deviation of the baseline. So, now if we this square plus sigma y dash square plus sigma z dash square square root divided by del x square del y square plus del z square. These are the components of the true length of the baseline. Now I will get a ratio in parts per million. Now this value I will compare, if we compare with these standards. So whatever is the ratio, from that I will be able to say what is the precision standard of the measured baseline. And for accuracy, what we need to do, already I told you, it is the error in length divided by true length. So this is also we will be able to get in parts per million, and this value we will compare with this to find out, to say that what is the accuracy of the accuracy standard we have achieved. So in that way we can compare, we can knowing the basic standard and then computing the values from the process data, we can know what is the accuracy standard or precision standard we could achieve, and subsequently we can say whether this accuracy standard or precision standard is satisfying our project need or not. If it does not meet the need of the project, then we have to redo whole of our work, or we have to find out what is the source of error, how we can improve the quality. That means the standard deviation can be reduced and mean can be improved towards thing. Now finally it is the network. So already we had discussed about the GPS network processing, where we do redefine the location of the control point, and when we are redefining the control point, we do get the position along with their standard deviation, and already I had discussed that the GPS networking is done through least square analysis, and during our point position we have seen that the position is defined by ATA inverse ATO, or in baseline also we have shown you, if we in this case weight matrix we have taken as unity, and in case of another we have that unknown parameter is defined like this. In this case this part is known by a matrix called QXX. Now from this is a matrix, we will get some parameters like that, and this is our QXX, this is our QYY, this is our QXY. So these values provides us the, now you can see here in case of GPS network, the maximum standard deviation along the major axis and minimum standard deviation along the minor axis is defined by these values, and where and the rotation angle is this. So these parameters we can get from this matrix. From this matrix these are the parameters from which we can find out the value of the angle T. Now we can substitute the angle T and to get and substitute these values from that matrix, then we can find out the maximum error along major axis. So this will define the error ellipse, and within that error ellipse actually we must have our control point position. So already I had defined, while we have deduced the GPS network analysis, we have discussed there, I had discussed about the error ellipse. That error ellipse is defined by making use of this, and our point should be within that error ellipse, if it is not, then we have to redo the network analysis, already I discussed. Other, if it satisfies, then we should go for accuracy, and for also accuracy measure again we have to do, because it is the point positioning. So, whatever I had discussed about the quality measures for positioning, that is what is to be also for GPS network control point. So, those has to be followed, and accordingly we should proceed forward. So, with this I can conclude about the GPS surveying, and so summarizing, we can say that to assess the quality of GPS surveying outputs, that means position, baseline or network, various standard of GPS surveying parameters and defined standards, various standards for, there are 4 basic standards for point positioning and 7 standards or order for baseline has been defined, and defined measures, that means precision and accuracy has been defined. Standards are designated in terms of root mean square error of the average set of square difference between data set coordinate values and the true or theoretical location. Planimetric position standard expressed in terms of radius of the circle of uncertainty on a datum surface and vertical height with a linear uncertainty value. Baseline standards are defined in ppm, parts per million. Quality of GPS surveying parameters are being tested using corresponding precision or accuracy measures. So, with this I will like to conclude today's class, and of course this is the fundamentals and basics of GPS surveying has been discussed so far. From next class we will be going to the another domain of digital lens surveying, that is the total station. I will be discussing on the instrument as well as how that instrument can be used for carrying out the surveying work. With this I want to conclude today's class. Thank you.